Okay, this was where we left, I guess. What are the practices? We were talking about what we were talking about. We were talking about the domains, supervised or unsupervised. And what are the practices? Well, actually, there are a wide variety of practices in deep learning, but the fundamental practices that we are going to focus in this course will be, first, understanding the data, extracting the necessary features, and understanding if we were able to extract the necessary features, which is feature visualization. It's also called deep visualization. We are going to see examples of it, because when you're building up a new deep learning system, most probably you'll be doing this in your lives, in your professional lives. The first thing you would ask yourself is it working? How to understand if it is working? The first question is, am I able to extract necessary features? Or what kind of features is the model is extracting? Most of the time, they could be, comprehensible for you. If it's an image, it extracts noses, kind of. You can understand it. But if the data you're working with is an earthquake accelerogram is there the earthquake takes place and there are accelerometers and they record something. So what is the high-level feature of an earthquake? Difficult to tell, right? You should be, I don't know, a civil engineer, PhD maybe. Still, the question remains, what kind of a feature I'm extracting? Because if the deep learning architecture is not extracting any high-level feature for you, it is most probably not working. So even if you understand, or even if you make sense of what the feature is, or you cannot make sense out of it, there is that feature being extracted, guys. That's the trademark of a deep learning system. Then the model training, okay. The model training and feature extraction part goes hand in hand, because if you're able to train the model, that means you're able to extract the features as well. And the most important part may be the performance evaluation, because in the end, you'll be asking the question, just like I said, is it working? How to understand if it is working? Because there is a large scale of data, thousands, millions of data. It can be working for an image, or it may not be working for that image. Is it working in general? How good is it working? Is performance evaluation, and we apply statistical methods for that. And believe me, for each deep learning problem, to measure your success, you will need a different type of evaluation technique. To understand a classification result, you have a different evaluation metric. To understand a segmentation result in an image, to understand the part of an image, or to understand an NLP problem. For example, you are converting a Turkish sentence to an English sentence. Is the sentence correct? You have some labeled data. For each Turkish sentence, you have the corresponding English sentence. You have found it from books, or you have a corpus. Well, how to compare them? How to get the distance from your result, your prediction, to the so-called ground truth. This is called the ground truth, the labeled data. What is the distance? So that would need a different type of evaluation metric, right? So we'll be talking about different evaluation metrics as well. Okay, so if you've taken Introduction to Data Science, DI students, I hope you've taken it. If you haven't, it's okay. So you know that data could be qualitative or quantitative. So quantitative data is like numbers, like the values of a pixel. But qualitative data is a bit different. We define things. Structured or unstructured. Multidimensional. 5-dimensional, 6-dimensional. Because if it is multidimensional, the type of features you're going to extract will be different. Spatial temporal or spatial temporal. Is it like a sensor-based spatial data that resides in space, or is it sequential data? Is it a relational data that I didn't mention, or is it something in hybrid, both relational or spatial, or temporal or spatial? For each type of data, different types of DL models will be used to extract those features to make the decision, guys. And different analysis and visualization tools should be used. Okay. So for visualization, this is something that I wanted to mention, guys. You can use both Python and MATLAB? Because for training the deep learning algorithm and doing the deep learning job, Python does an extreme job. It does the best job because you have the most architectures and libraries, the best libraries in Python. But in MATLAB, you have very nice visualization tools. So this is my experience. Most of the time, I find myself doing all the training and deep learning stuff in Python. And when it comes to visualizing and understanding the results, I'm in MATLAB because I'm used to it, visualizing data. But you can do them in both. Okay. So model training. At this point, you theoretically understand what to do with the training. Okay, we are going to write codes, there will be data, we are going to train the data, but where? Where is that data? Which platform? Will it be my computer? People say that it is difficult to do it in your computer because you need a GPU. I don't have a GPU. People say that there are clouds, so the environments. I'm going to briefly talk about the environments as a part of the introduction to this course. Okay, just like I said, some say it is all in their local PC, they have a good GPU. Some say it's all in cloud. What is better, what to do, and what you can do in your projects. And you've seen these Colab, Google Cloud, or Amazon SageMaker, Amazon Web Services, AWS. What are those? There are several alternatives, guys. First, you select the language. And I strongly recommend Python because it's not Python. You are limited to a very small environment. I'm imagining we are going from Python. You choose a DL library. There's a strange thing about Python. If you have never used Python, how I would define Python to a person who has never used Python is, in Python, you don't learn the language, you learn the library that you use. So it is like you don't know Python, you actually know PyTorch. It's like you don't know Python, you actually know TensorFlow. I mean, you can both know Python very well, the base fundamentals of the language, or you can learn all of them, I don't know. But somebody who is not coming from computer engineering background, I'm imagining that they would know all the programming languages and taken Python as a fundamental course in their lives. Who has programmed in another language and come to deep learning for deep learning practices and started to use Python as a tool for deep learning for those guys, which is most of you. You should understand that the Python you're going to learn will be mostly limited to the DL library that you're going to use. Because the way you're going to be accomplishing something in Python Keras, Python PyTorch, Python TensorFlow, or something other, there are others as well, will have differences. Sometimes small differences, sometimes very extreme differences, guys. Okay, is it going to be in my computer or is it the cloud? If it is a cloud, which platform? Colab, Amazon, or my computer? Should I install an integrated development environment like Anaconda Spider, PyCharm? People use PyCharm. Well, they all have pros and cons. We will be in our labs working with Colab because it is, in our experience, the best choice for a laboratory session for a course like this. And it's going to be teaching you the main subjects, how to use Python and what is libraries and stuff. And the funny thing is when you learn deep learning in a library, in the environment, you most probably are going to stick to it because things will be easy for you. It's very difficult if you start in PyTorch. It's not easy to switch to TensorFlow. I mean, at some level you can, by the way, because after some level they look somewhat similar. Okay, Python is a winner because of many reasons. And the most important reason of all is nearly all state-of-the-art studies can be found open source in Python. So if you don't want to follow the state-of-the-art from like 5 years behind, use Python. And 5 years is like a century in deep learning, guys. Okay, and that's the most important reason. DL library. Okay, if we can say that, we can safely say that the war is won by Python for programming languages, which is the library. There are two giants. There are many different libraries, and they have different applications. For example, for embedded deep learning systems, people use Theano, Lasagna, different types. However, in the world of deep learning, most of the algorithms are either in PyTorch or TensorFlow. For industrial platforms, TensorFlow seems to be more powerful. For academic platforms, PyTorch seems to be more powerful. Somebody coming from the academic background, I feel myself closer to PyTorch as well. So I recommend you use PyTorch as well. However, TensorFlow is also very powerful because TensorFlow is a product of Google. And most of the important stuff is done by Google today. And it's shared open source, including most of the papers. So most probably in CVPR 2022, there will be some important papers which would mark this year. And they will be done by a group from Google, which would mean that it is TensorFlow. So if you're serious about deep learning, never be so far away from TensorFlow, guys. But we are going to be teaching things in Colab and PyTorch, because at the introductory levels, I think PyTorch is easier to understand, in my opinion. Okay, so let me continue. Just like I told you, in different fields, like embedded stuff, different libraries are used in those small clicks. I have a student who is working on applying deep learning to binary systems like FPGAs. And there is society for that, and they widely use Theano because Theano was specialized in embedding some part of a convolutional neural network to an FPGA in binary codes. That's why it grew on top of it, and it's being used that way, for example. So never forget that. And if you're planning to do something embedded, please let me know in the project. And the DI platform. So the first choice, are you going to do it in your computer or in some cloud system? So we're going to be doing the labs in Colab PyTorch, which means that you will have some sort of cloud computation capacity. However, Colab cannot provide the capacity it used to provide as they did in the previous years. The demand is increasing and Google cannot, I guess, afford it. But still there is capacity and you will be able to do some experiments, maybe slower. Excuse me? Yes, but you can use some of their GPUs for a limited time, which is shrinking as the years pass. So, or if you're a gamer, I don't know, if you have some sort of CUDA compatible GPU, which are NVIDIA GPUs, if you have one of the older ones, even one of the older ones, I don't know, GTX 600 something or 1000 something, older ones, they are very cheap. I mean, they can handle, you don't have to play GTA 5, I don't know. I have one, something simple, and it kind of makes it 30 times faster than the microprocessor, which is something, by the way. If it's going to take 3 days, it takes 1 day, and it makes sense. Use it. So if you have some sort of GPU, which is CUDA compatible, check its CUDA compatibility level in Wikipedia. If it matches the CUDA compatibility requirement of PyTorch, because as years pass, every new library come up with a higher level of CUDA compatibility requirement. They say, now I'm going to be working with a CUDA compatible GPU, which are higher than this 40, for example. Just make sure that your old GPU, if it's an old one, or if you have a newer GPU, just forget about the environment, cloud environment. Use it in your computer. I mean, you'll pay like 20 liras more in your electricity bill, maybe, but it will be worth it. Okay. So what is the pros of the cloud platform: no installations for your environment. It's going to be just ready for you. And these platforms provide limited GPUs. So that's why if you have a GPU at home, which is CUDA compatible for your library, use it your device. In your locals, I use Anaconda Spider. The reason I use Anaconda Spider is, it is like MATLAB. You can visualize the variables. You can debug it, stop it anytime. So it is not like a programming environment. Anybody coming from the electrical engineering background love Anaconda Spider. Anybody coming from the computer engineering background, they love PyCharm. So these are like, I don't know how we are used to doing things. So I'm just trying to give you my perspective. I've always been doing things with MATLAB up to a point. In MATLAB, you can just run command line commands so that you can stop the code, run something, analyze it, look at the workspace and variables. If you've used MATLAB, you know what I'm talking about. Anaconda Spider is like Python, MATLAB-like environment. That's why I assume it is MATLAB. The downside about this is, they are not very easy to install. And they're easy, by the way. They're easy. It takes, I mean, I've now, because I had to move from environment to environment to a new desktop, I've changed places. And when you move, you have to install it again. It takes like 15 minutes for me to install Anaconda Spider, PyTorch, and related libraries if I have CUDA libraries, if I have a GPU. But it was not 15 minutes when I did it for the first time. But it shouldn't frighten you guys. There are incredible number of websites. Question? No, sorry. I thought after the voice, sorry. Okay. Yes, you're right. It is slower. Yes, yes. I understand. People not coming from an engineering background, don't get me wrong. Actually, the department is called computer engineering, but they are actually computer science people. People coming from engineering background love that slowness, I should have said. Because you're definitely right. I should have said that. Anaconda Spider is slow, guys. If you don't like it slow, and if you're going to say, well, it's not still opening, don't use Anaconda Spider. But if you want to make it slow, you want to make stop, analyze, look at it, just like MATLAB, that's the place. And one of the assistants of our department, right, Ece, you are an assistant of our department, right? She says, doktor öğrencileri, the PhD students can use Truba sources as well. Truba is an online cloud platform of TÜBİTAK, and PhD students can use it as well. It's not difficult, but we don't have much PhD students, right? Here, the only, you're PhD students. Just know this. So limited amount of time, you can use Truba as well. Okay, thank you, Ece. Okay, so we are about to come to an end to this introduction. What to do until next week? Choose your environment, or at least make a search about the environments. As I told you, your teaching assistant will make a laboratory soon in the 3rd or 4th week with Colab and PyTorch. If you're going to be accepting that choice, then make a search about Colab and PyTorch, what it's all about, so that you'll be prepared for it. Or maybe you have a GPU at home and you want to use it. Then start searching for, or make a research on what kind of local environments I can use. I told you Anaconda Spider, but there are others as well. And just read about, there are nice blogs. Try to choose an environment. And if you can set it up. I have some additional pages for references. If you want, you can check. I will always have them. And think of a project idea. If it can be related to your thesis, I'd love that, because it motivates the students, okay? And it will be helpful for your thesis as well. If we could do a little part of a chapter in your thesis, well, why not? Okay? And I love when Andrew Vanji says this. Take courses of Andrew Vanji. It is very nice. introductory level deep learning courses, and he always says this, and it became like a meme in the internet, meme, because he always says that. Don't worry about it if you don't understand. And when you're doing this research, there will be parts that you won't completely understand. Don't worry about it if you don't understand. Okay, these are the additional references, guys. This is all I'm going to be doing for the introduction and for today. Now I'm ready to get your questions. Okay, and Barış Deniz Sağlam has a chat message. He says, apparently he's using Jupyter Lab, which is a more interactive version of the Jupyter Notebook. It provides nice integrated development environments, features as well, he says. You can visualize things. So if you want something in between, practical as Jupyter Notebook, but not as, I mean, how can I say, slow as Anaconda Spider, that's a choice. I've never used it. I know, he says, I'm not using that. He says, I'm using VS Code. Okay, he says it's nice too. Okay, any questions or opinions or anything to say?
Hocam merhabalar, öncelikle teşekkürler. Ben bir şey sormak istiyorum. Acaba düzenli olarak attendance almayı düşünüyor musunuz? Yoksa bu kayıtları hani sonradan izleme şansımız olur mu? Bu sizin için sorun oluyor mu?
Okay, okay, thank you for the question. Your friend is asking, what about the attendance? And are you going to upload the courses to YouTube? I'll repeat my explanation for this part. I won't take attendance. So about the YouTube part, if I could record it, guys, if there's no problem, I will put it to YouTube. And it will be unlisted, I mean. It will be public YouTube. So yes, but just like I said, sometimes the computer crashes because we are doing Zoom, we are doing a presentation, and we are doing recording, and sometimes it is too much for it. And in the previous 2 years, while I'm doing this kind of lectures, it happened to me. I lost the record. If I lose the record, I won't be able to put anything. But if I don't lose it, I'm going to put it. So that will be the definition of the hybrid. And Begum asks in chat, is it going to be a hybrid class again? Yes, guys. Until the midterm, I'm planning to do all courses hybrid in the classroom. Okay? Answer to your question. After the midterm, we'll see. I don't know what's going to happen after the midterm, I mean, after November.
Hocam, peki midterm is like I am also a student from previous image processing course. Hi again. The midterm and final is similar to that one?
Well, Begum asks about the operation of the midterm and final, just like you asked. Well, I don't know about it yet, Begum. We'll see. I mean, I would like to do a classroom examination, but I'm going to decide it in the following weeks and will announce you, okay? So it's going to be a proper exam. Don't worry about it. But we'll see. Okay. Barış asks, do we have to attend the courses? No, there is no attendance. Barış is asking, do we have to attend the courses in class? Well, you are not in class right now, Barış. I just didn't understand the question. Or are you in class and chatting at the same time? Then joke.
Hocam, I thought, I mean, there's a mandatory attendance in classroom. No. So you said no, right? Okay, thank you.
Okay. Okay, guys, next week, I'll be uploading these slides for next week very soon. We'll be slowly starting about classification in a feature space. So the concepts we are going to cover next week will be related to more machine learning stuff, but since we are assuming that you haven't taken a machine learning class, although some of you have taken some, but we are assuming that you haven't, and there are guys who has never taken a machine learning class, we are going to be talking about the feature spaces, how to classify features in a feature space. What is a feature space? Why feature spaces are important and how they are selected. Okay. So if no questions, thank you very much. Zoom session. Are we
Hocam
okay?
ben bir şey sorabilir miyim?
Var mı? There's a question. Please.
Ben en başında kaçırdım sanırım da Begüm'ün sorduğu hybrid class olacak mı next week diye sormuş. Hybrid
Yes.
class'tan kastınız şey hem Zoom'dan katılabiliriz hem
Hı.
en class hem de YouTube'a eklenecek ve midterm'e kadar böyle gidecek.
Exactly.
Tamam, teşekkür ederim. Sonrasında da
question.
kapanmadan bahsettiniz galiba.
I don't know what's going to happen after the midterm. We'll
Tamam.
see about that.
Teşekkürler.
No new question. Don't worry about it. Okay. Then I'm kind of concluding the lecture, guys. Thank you. Thanks for coming for Zoom and lectures classroom. Okay. I'm stopping the record. Stop the record.